This week in the AWS Developers Podcast, we're talking about ECS Managed Instance. Good morning. Every Friday morning in all good podcast applications, there is a new episode of the AWS Developers Podcast. This week, we're talking about containers and one of the many ways to deploy containers on AWS. ECS with my guest, Oli Pomeroy. I hope I pronounce your name as much as I can, as best as I can with my French accent. Your specialist essay for containers. So maybe let's start there. Let's not assume that all listeners knows all the different ways to deploy a container on AWS, and we are not going to talk about all of them, just one. It's ECS, Elastic Container Service. What is ECS?
ECS is a fully managed container orchestration service. And it makes it really easy and simple to deploy containerized applications in the cloud. The idea behind it is you package up your application as a container image, and we'll make it really easy to then run that in the cloud, schedule it on serverless compute or schedule it on EC2 compute, keep the containers running, restart them if they stop, make your application highly available, all of those good things that you expect from a container orchestration service.
Let's eliminate the elephant in the room. There is a very popular container orchestration service called Kubernetes. Everybody's talking about it. We have a managed service for Kubernetes as well. It's called EKS. So how would you... What's the mental model for a customer to choose to deploy on ECS or EKS?
Yeah, it's a good question. Actually, I guess I'll start with a little bit of statistics, because I think these are actually really, really powerful. So like new container customers that come to AWS, over 65% of them deploy their workload on Amazon ECS.
Wow, that's more than 1 out of 2 deploying on ECS versus EKS or other solutions.
Right. And like just to give an idea of scale, like over 3 billion Amazon ECS tasks are launched every single week. So
what is a task? It's a container that starts and stops.
Yeah, it's a container. It's a package. It's a unit of work.
Repeat that. 3 billion.
3 billion ECS tasks are launched every single week.
Per week. Okay. That's one of the things I love with AWS. Every time we mention metrics, the numbers are mind-blowing. 3 billion per week. So that's the scale at which we operate ECS for customers.
Yeah, absolutely. And the thing is, Amazon ECS integrates really, really nicely into AWS and lots of different AWS services. So when building on AWS, and you want to run containerized workloads, ECS is a really, really nice fit. Like if you're standardizing around the AWS API, then ECS is great. And Kubernetes is there, as you mentioned, and for customers that are standardizing around the Kubernetes API, that makes a lot of sense as well. But it doesn't even have to be either or as well. We have a lot of customers that run some workloads on ECS and other workloads on Kubernetes. It's a really, really nice, offering of services.
My mental model is that if a customer already uses Kubernetes on-prem or on another cloud provider, then it might make sense for the same workload to choose EKS. But if it's a net new containerized application, then maybe it's easier to get started on ECS.
Yeah, absolutely. Yeah, ECS, as we mentioned before, because so many new customers use it, it really leans into making it easy to get started, to deploy your first container workload, to help you get that application up and running with lots of really nice, sane best practices. So you don't have to go and learn lots of different knobs and things you need to tune and turn. It's just a great way to get a workload going.
And the only thing is that we don't call a task. We don't talk about a pod. It's called a task. That's the main difference.
So a task is a unit of work, the same way that a pod is a unit of work. But in theory, they're the same thing. They're a group of containers that you want to schedule together. So it could be like your application container and a monitoring container or something like that. We'll call a task.
And at the beginning of ECS, customers have to choose a pool of EC2 instance and tell ECS, hey, this is the cluster to use to start the different task. And then over time, we introduced another deployment model called Fargate. Can you explain the two, maybe from an historical perspective, where we start, why we add Fargate?
Yeah, absolutely. So ECS as a container scheduler is actually over 10 years old now. We actually had an anniversary last year.
Hey, happy birthday.
So when ECS first came out, the ECS was the container scheduler, and it would run workloads on Amazon EC2. So the customer would provision a number of EC2 instances, or the autoscaler will provision some EC2 instances for you to run your workloads. And then over time, customers were asking AWS to take on more of the responsibility of managing that compute. So actually, over 5 years ago, we released AWS Fargate. And Fargate was a serverless compute engine for containers.
Serverless means I don't have to manage any server?
Right. The underlying compute is in an AWS account. The operating system, the patching, the maintenance is all handled by AWS.
So the big difference is that I don't see the EC2 instance in my account, but not only I don't see them, but I don't need to manage them. I don't need to patch the operating system or take care of whatever is there. I know it's there, and AWS takes care of that for me.
Correct. Yeah, and it also moves to a really nice pay-as-you-go pricing model as well. So with Fargate, you're only paying for the size of the task, and obviously while the task is running, which is slightly different to EC2, whereas you're paying for the EC2 instance, whether there's a task running on it or not, or whether the instance is underutilized or not, you're still paying for it. Whereas on Fargate, it's a nice pay-as-you-go model.
So it's much closer to the Lambda pricing model, where you only pay for invocation or for the time the CPU runs to handle your request.
You're paying for the time the task is running. Mm-hmm. So there may be times where the task is running and you're not serving requests, and that's hopefully when your autoscaler kicks in and scales down your tasks. But yeah, it's paying per task.
And it can scale to 0.
It can. That's especially for some of the batch workloads, data processing workloads. It's really nice because it can scale based on queue depth or on when work comes in. For web workloads, there's a little bit of time to handle serve that first request. So we often advise customers have a few tasks running just so user experience is good. But it definitely can for some of the other different workload types.
So that was the situation until a few weeks ago. When I want to create my ECS cluster, I have to choose between EC2 Managed Instance or Fargate, where I don't see and I don't manage any instance. But apparently, we received some feedback from customer. They want something in the middle. So what was the challenge that our customer had with the previous proposal, EC2 or Fargate?
Absolutely. So EC2 was great for customers that want to use the plethora of EC2 options, all the different instance types, all the different instance families, the flexibility of all the different pricing models. There's lots of great features that come from EC2, and Fargate's great if you want to pass off some of the management responsibilities over to AWS. But it's really sort of general purpose compute that you get on Fargate. And so there were customers that want some of those managed benefits that you get with Fargate, but can't quite get there because there's specialized requirements to their workloads.
For example,
there's examples like financial services customers that need a particular processor and have to have a particular processor SKU for reliability of their workload. Or maybe they're doing some sort of machine learning inference and need to have GPUs or accelerators. Or maybe it's a big data processing workload that is moving so much data around that it needs some of those high network throughput instance types. And these things just aren't quite suited for Fargate today and its general purpose compute. And so they had to stay on EC2. But as we mentioned, those customers wanted some of those managed benefits, like a a patched operating system. They kind of want to offload that to AWS, and that's what ECS Managed Instances gives you.
So a very naive question from my side. We could have had more choice in the capacity of Fargate. Like when I create my Fargate cluster, I say, oh, I can choose a GPU or an AMD processor or this or that or that.
Yeah, you could, but I guess the challenge we would have at that point is you're almost constantly the chasing EC2 and chasing the EC2 roadmap. There'll be like a delay, right? Like EC2 will release an awesome new feature, and then there'll be a little bit of time before we could catch up on the Fargate side. Whereas with managed instances, that's no longer a concern because we're using EC2, we're using the EC2 APIs, the instances are in your account. There's no real delay on that sort of stuff.
So that's exactly what we want to talk about today. That new offering that stands in between the two, in between EC2 and Fargate. It's called ECS Managed Instance. What are we proposing to our customer?
Sorry, how do you decide which one to choose?
Yeah, what is this new offering, EC2 Managed Instance? What is it?
So ECS Managed Instances is that idea of a compute option that gives you the flexibility of EC2, but the managed experience of Fargate. So you can
you elaborate that a bit? I'm
curious
absolutely. There.
Mm-hmm. So what that actually means is you can choose all the different instance families, like the high network throughput, the GPU accelerator, as well as the different pricing options in EC2. So whether that's things like reserved instances and stuff like that.
Saved price and
correct. Yep. Yeah. But the actual operating system is managed by AWS. So even though there's an instance in your account and you get lots of flexibility on what that instance looks like, it is actually managed by AWS. Will handle patching that operating system, retiring it, things like that.
So it means I need to authorize AWS to connect to my instance to do things on the operating system. I guess it goes through SSM or a similar mechanism.
So the first thing you actually need to do when you want to use ECS Managed Instances is you create an IAM role that you give to the ECS control plane that gives it permission to create and manage those instances in your account.
So as a customer, I'm in control of what the ECS control plane can do on my instances.
Right. And you can actually see in CloudTrail, like the API calls that the control plane is making when it sort of provisions and requests these instances.
And what are the type of operation that ECS is doing on the instance? You mentioned patching the operating system, but I guess there are many others as well.
So if you think about the life cycle for customers that use ECS on EC2, the first thing they have to worry about is they have to decide which AMI should I choose, and so they have to go away and choose those AMIs. No, we have ECS optimized AMIs, but it's on the customer to notice when we release a new one and then sort of migrate their fleet to it. And if they're using some of the like GPU or accelerated instance families, and then there's also a little bit of a question on drivers and making sure the driver stack is where the customer needs it to be. And all of that goes away with managed instances. You don't have to worry about choosing an AMI and managing that. That's something we do. We create the launch template. So when you want to provision an EC2 instance, you normally create a bit of a launch template around what you want that instance to look like. That's also something that we take care of. And then once that instance is up and running, it then becomes our responsibility. And the way that happens is that each instance that you create with managed instances actually has a maximum lifespan. We will run that instance for 14 days. And after that point, we'll say, okay, to guarantee freshness, to make sure we pick up the latest AMIs, to make sure that instance stays up to date, we'll migrate the workloads off it to another instance and retire it. So we're taking care of the life cycle, making sure there's freshness, making sure there isn't any out of date or insecure packages running in your fleet.
And I guess we don't kill instance like that. We create a new one, migrate the task, and then when there is no more task running, kill the terminate, to use the EC2 terminology, terminate the instance.
Yeah, correct. Yeah. So when you provision the instance, it has 14 days until we place it in draining mode. And when an instance gets placed in draining, what that happens is we basically signal that we want to stop all of those running workloads. And what ECS does is it has a start before stop lifecycle. So what it will do is it will replace that workload. It will start a new task somewhere else in the fleet, or if there isn't any capacity available, we'll provision a new instance. And then once there is replacement tasks running in the environment, we'll then shut them down on the old instance. And then once that old instance is empty, we then terminate it. So your instance can actually run up to 21 days. So we give you that 7-day grace window for us to migrate the workloads off.
And I guess there is an ECS agent to install, and we will install that ourselves as well. It's not the responsibility of the customer.
Yeah, correct. Yeah, so all parts of the underlying operating system, including things like the container runtime, the ECS agent, are all managed by AWS. So
what if
have to worry about
the application requires? What if the application today requires? I don't even know if it happened in the world of containers, but requires some specific drivers or specific installation at the operating system level, not at the container level. Customers are still access to this machine. I can customize the AMI.
You can't customize the AMI. So there's a few things to talk about there a little bit. So the AMI that we use in ECS Managed Instances is the Bottle Rocket operating system. So the Bottle Rocket operating system is a container operating system that built by AWS that is open source. And because it is a container-focused operating system, there's lots of like the things you expect to find on a general-purpose operating system.
It's not there.
are not there. So, like for example, there is no package manager. It's actually a read-only file system on Bottle Rocket OS, and so there's a really nice security story around using managed instances because it's a lightweight host, and there isn't if somebody escaped from a container, there isn't much they can do on the box without a package manager or some of their utilities.
Yeah, it reduced the surface of attacks.
Correct. So when your comment of if you needed to like install things on the underlying operating system, you won't be able to do that because of the characteristics of Bottle Rocket. The one thing I will say though, one of the things or benefits you get with managed instances that you don't get with Fargate is that because the instance lives in your account, you're actually able to run privileged containers and do things like instrument the kernel with eBPF probes. So some of the monitoring and security runtime tooling that give you nice visibility into your application by putting probes into the kernel, you can actually do on managed instances that you can't do on Fargate today. But so there is some visibility into the host that you get, and but it's still a managed operating system.
And I guess the same way there is no package manager, there is no SSH daemon or things like that. So anyway, we cannot connect to that machine, which is good for security because we should not. Don't touch that.
Correct. Yeah, because customers are restricted from SSHing onto the machines, and you can't use like SSM to get your own connection or anything like that.
But this machine runs in my VPC. They have access to protected network resource if they need to, and I can control the network aspect and the connectivity aspect of that.
Correct. Yep. You control which subnets, you control the security groups, you can even turn on things like VPC flow logs to see what's going on.
So what's the user experience? If I'm a customer, I go to the ECS console, I want to create a new cluster. I notice there is that third choice. So we have EC2 self-managed on the left side of the console, Fargate on the right, and there in the middle. And it's a nice place in the middle because when I first read about it, I say, yeah, it's really a middle ground between the two. And then I saw the console and yeah, it sits in the middle physically as an option there. So I start choosing ECS Managed Instances and then what?
Yeah. So the way that we manage the different compute options in ECS is through a terminology we call, or an abstraction we call capacity providers. And capacity providers are what you create inside of your cluster. And then what you'll do is then attach workloads to capacity providers. So, for example, Fargate would be a capacity provider, and you say this workload runs on Fargate. Or you would create a auto-scaling group capacity provider, which is what you would use if you want to use EC2 instances. And you say this workload is attached to the auto-scaling group capacity provider. And at any point, you can actually now go into your service and you can change the capacity provider. So if you actually wanted to migrate a workload from EC2 to Fargate, you can do. You can just update your service, change the capacity provider from an auto-scaling group-based one to a Fargate-based one. And so we've used this abstraction to create managed instances. So you'll create a managed instance capacity provider in your cluster. When you tick on that box in the console, you can just put in the IAM role that we talked about before to give ECS permission to create instances, and then you provide the subnets and security group that we need to place those instances. And if you want to, that's it. Like, you don't have to do any more customization. And what we will do is we'll create a default or a general purpose managed instances capacity provider. And so this is a capacity provider where when a workload is scheduled, we will pick one of the general purpose EC2 instance types. And we'll pick an EC2 instance type and size that closely matches the scheduled workload. And so we'll do our best to try and bin pack as many of those pending tasks onto as fewer instances as we can. Caveat that we will always try and distribute them across availability zones first for high availability. Mm-hmm. After we've distributed them across across availability zones, we will then bin pack them into as fewer instances as we can for efficiency and to save costs inside of each AZ.
Does it use the auto-scaling as well? It creates an auto-scaling group that I can see in my console, or it manages its own auto-scaling to create more EC2 instance, auto-scale down?
Yeah, good question. That's actually one of the big differences between traditional EC2 on ECS and the new managed instances, is that managed instances does not use auto-scaling groups. We will directly provision instances using the EC2 Fleet API. So it's actually a lot quicker to get an instance up and running. And the way that it works is that a workload or a task is scheduled. We will then look inside of our like the existing managed instance capacity, like, is there space in your provisioned instances to run it? If there is not, we will then make a call to the EC2 Fleet API to provision a new one based on the size of the task. So a bit different to auto-scaling groups, whereas like all instances in an auto-scaling group will probably be around the same size. You kind of put in the requirements for your auto-scaling group. Mm-hmm. That's not the case here. We'll make a scheduling decision depending on what is the most cost-efficient way to run that workload.
Cost efficient, it rings another bell. I'm sorry, I'm curious, so I'm drilling, I'm diving with my curiosity, trying to follow you. You say cost efficient, it means can it work across different types of EC2 instance, spot instance versus on demand?
No, so it'll stay within the same pricing option. So it'll stay within on demand. But for example, if there is only one task in the queue and there's no other capacity in the cluster, we'll pick a small instance type. Okay. But if there's a lot of tasks in the queue, we'll bin pack those together and maybe provision like a 4XL or something like that, whatever is the most efficient way to run that. Once again, caveat, we'll distribute across availability zones first, and then bin pack within each availability zone.
And you said that by default, it will choose a family of EC2 instance for me, but the by default is interesting there. What if I don't want the default? What are my options?
Yeah, so when you create that first, or when you create your capacity provider, you can just tick the default, and it's almost like a Fargate-like experience where you'll get general purpose compute from like the C, M, and R families. But if you are using managed instances because you want a specific instance family, or you want a like one of the different compute options, maybe accelerated compute, maybe high network optimized compute, then what you can do is we'll use attribute-based selection, which is an EC2 feature where you put the attributes that you want for your instances into your capacity provider, and then we'll provision EC2 instances based on those attributes.
So an example of attribute would be GPU equal blah blah, or memory size, this or that.
Yeah, so it could be CPU and memory sizes, but it could also be like a specific instance family. So for example, you could put like, I want to run on C5 with a wildcard, or you could put the CPU manufacturer is AWS, and then you'll get a Graviton-based instance. Or you could do a bit of both. You could put the CPU family is AWS, but the instance family is like C8G, and then you'll get yourself Graviton 4 instances every time for customers that want to leverage the latest and greatest Graviton.
So there is a great level of flexibility, of granularity that our customer can choose to choose the exact type of instance or characteristic of the instance they need for their workloads.
Yeah, absolutely. And like if you think about customers coming to use the GPU workloads in particular, a lot of customers have specific requirements that needs to run on this particular G type instance type or P instance type, whatever it may be, and so you can choose the accelerator, or you can choose the accelerator manufacturer or the specific instance type to really hone in what we'll provision.
Can I mix? Maybe it has no sense at all. I'm just dreaming. Can I mix different capacity provider? Like if some task on Fargate, some other on ECS Managed Instance, some other on EC2?
You can mix capacity provider in a cluster. So your cluster can have some services on Fargate, some services on managed instances, and some services on EC2. But within the service, you cannot. Yeah, so like a service has to be pinned to managed instances. And if you ever want to change it, you can say just update that capacity provider. So if you had a service running on Fargate today and you wanted to see what it was like on managed instances, you don't have to create a new task definition. You don't have to create a new service. You can just update that service by switching the capacity provider, and it run it on managed instances.
That was my next question, how to migrate. If I have an existing cluster running on Fargate or EC2, can I easily, progressively migrate to ECS Managed Instance?
Yeah, absolutely. So the first step, you'd create that new capacity provider. And then the second step would be to update the service. And that will trigger a new deployment. So if you're using if it's like an ECS rolling deployment where we like start a new task and then shut down an old one, we'll do that, sort of start a new one on managed instances, shut an old one down. Or if you're even using something like the new blue-green deployment strategy, we'll create all of the new set of tasks on managed instances and shut them down.
And then progressively shift the traffic towards the new set of tasks, unless there is an alarm that triggers, and then we stop shifting the traffic and we send the traffic back to the blue or the origin, whatever is your color of.
Yeah, depending on what your deployment flow is. But yeah, we'll handle the traffic shifting between the old and the new.
What's the use case for a multi-capacity provider strategy? Because I asked the question a bit out of the blue, like that, saying, hey, maybe it's cool, but I have no idea why a customer would like to do that.
So it is actually something you can do for Fargate today. And the reason why you can do it on Fargate today is because Fargate On Demand and Fargate Spot are two different capacity providers. So if you had a workload that you want to run on Fargate today, you could say, I would like a base capacity of my workload on demand, and then some of the burst capacity can burst out onto Spot. And so there is a use case for it, but you can't sort of mix and match across the different compute options.
And we mentioned Spot twice already, but I'm not sure we clearly answered the question. Can we use a Spot on EC2 Managed Instance today?
Not today, not at general availability of managed instances, but that's something we're working hard on, and it's hopefully something we'll see in the next few months.
Yeah, I'm pretty sure there are a lot of customers asking for that. Spot is a great way to reduce your cost on EC2. Talking about costs, what's the pricing? And I don't want to talk about US dollar because it's different in every region. But how is it if we compare that to Fargate or to traditional EC2 deployments?
Yeah, so the pricing model, the way that it works is the customer is billed for the EC2 instance. So we provision an instance, the customer is billed for that. And that
the
will come
normal
up
price of EC2?
As the normal price of EC2, and it'll come up as an EC2 line item in their cost and usage reports. And if they have things like reserved instances and savings plans, they can use that against that EC2 line item. And then there is an additional ECS management fee per instance, and that's just an additional cost that we charge on top of the instance fee as part of the lifecycle management.
So it's per instance, so per milliseconds as well, or seconds, like an EC2 instance.
Yeah, correct. Yeah, so that's slightly different to the Fargate pricing model where you're paying per task. You're back to paying per instance.
Yeah, because that's the resource that we allocate for a customer for a period of time. I guess that with Fargate, it's a bit more like Lambda, where we co-host different tasks from different customers on the same physical host.
So slightly different on the Fargate side. Fargate, you actually do get a dedicated EC2 instance for every Fargate task you run.
Okay.
But we build to customers for the task size.
Oh,
whereas on managed instances, we actually put multiple tasks on the same instance, and like the job of managed instances in ECS is to drive up the utilization of that instance by bin packing as many tasks as we can on there. And actually, one of the things I've not actually called out is there's some consolidation logic as well that managed instances does.
What do you mean?
So every time there's an event in the cluster, like a service scales up or down, we'll look and say, are we optimized? Is there any way that we can shuffle some of these tasks around and maybe free up an instance and remove it, or drive up the utilization of what we have? So we're constantly evaluating the estate and seeing where we can consolidate instances and save the customer cost.
If one of our listeners wants to try ECS Managed Instance, are there any, how can I phrase that? Is there any specific consideration they have to think about before starting using it? In Amazon jargon, we say, is there any one-way door, a decision that I cannot reverse easily? Is there any limitation that I should know about?
So depending on where you're coming from, if you're a Fargate customer today, you can just update the capacity provider to managed instances, and it will move, and you can switch back and forth. It's a very, very easy exercise. If you're an EC2 customer, for the most part, it's very seamless to move over to managed instances and go back and forth. But there are a few different parameters that EC2 customers can choose. Like, for example, there's a different networking mode called the bridge networking mode on EC2 that we don't support on managed instances. So there may be one or two things that you might have to change on your task definition if you're an EC2 customer before you can move to managed instances. So you may have to, as I say, change networking driver first and then move to managed instances. But if you're already on like an AWS VPC networking driver on EC2, then it's a seamless back and forth as well.
And we have a lot of application developers that are listening to us as well. Is there anything an application developer, I mean the person that are building the application inside the task, should know about, or is it totally transparent for the task?
I guess that's one of the benefits of containers, right? You're abstracting away the application from the different compute options. That being said, if the application you're building has specific requirements on driver sets or hardware, they may need to know a little bit more about where they're running. But if you're an application developer today that's packaging up a microservice in a container, nothing really to consider for managed instances. You
So
might just get
for really large customer where it's a different team managing the cluster and developing the application, they don't need to talk. the admin team can upgrade the cluster without letting know the application developer.
Yeah, that's correct. Yeah, we have quite a lot of customers out there that are building these developer portals or developer platforms on top of ECS. And if they go down that path, then yeah, absolutely. A platform team can build a platform on ECS, can choose their capacity providers, and then the application team is running their workloads.
Container is almost a standard way now to deploy application. Like 20 years ago, everybody was talking about VMware. Now it's roughly two families of deployment, at least with my conversation, with the conversations I have with customers. It's either they go container, either they go serverless, and I know that it's a bit blurry with Fargate. It's also serverless, but when I mean serverless, I mean Lambda or container application. What are the big trends you're seeing in the industry right now in terms of containers deployment?
Yeah, so there's a few really interesting things going on in the container side. The first one I will say is there's a lot of people out there today running machine learning models or building AI agentic flows in containers. It's actually quite funny that when you look at these agentic applications, they actually start to look like microservices. And whereas the best place to run microservices is typically on containers. So we're seeing a lot of people kind of moving those agentic workloads, maybe running inference workloads, self-hosting machine learning models in containers. And there's lots of exciting things around the framework side and how different frameworks are taking advantage, like Strands, for example, are taking advantage of containers and the various container orchestrators. So there's a lot of that going on, which is really cool. And we're also seeing a lot of people standardizing on, and I mentioned them before, building these IDPs, building these developer portals or developer platforms, on top of the container schedulers. Like they decided they want to use the cloud. They decided they want to use containers. Platform teams are now building their platforms on top of ECS or on top of EKS, and then offering that out. And so we're seeing a lot of sort of cloud center excellence teams or platform teams that are building platforms today.
That's a big topic indeed, and we talk about that in the AWS Developer Podcast. If you go back to the episodes in May, I interview someone from Adobe that explained how they built their developer platform. It was on EKS, sorry, not on ECS, but it was still on AWS and with containers. So if you're curious about building platforms, check that episode, and the links are obviously in the notes of this podcast. Anything else I should ask you before we conclude this episode?
Anything else? Nothing
Is there
springs
any
to mind.
message that you couldn't pass, you didn't pass?
The one thing I will say is it's coming up to reInvent time. There's lots of exciting ECS sessions at reInvent. So I will do a shameless plug on behalf of all of my colleagues that are presenting ECS content. That if you're going out to Vegas, just take a look at some ECS sessions.
That's a nice teaser. It means there will be new stuff on ECS as well.
Absolutely, there's some exciting things coming.
So stay tuned for more new things on ECS, EKS, and the other deployment platforms that we offer you here at AWS. Thank you very much for your clear explanation about ECS Managed Instance. Oli Pomeroy, your specialist essay for containers. You're based out of London, if I'm correct?
Correct, yep.
In London. Thank you very much to you for having listened to this episode until the end. See you next week for another episode, but now go build.